Hello everyone, my name is Akash Patel and welcome to my presentation on model tuning and optimization fundamentals. So this presentation is a part of my AWS Certified Machine Learning Engineering learning journey. In our previous presentation, we learned how machine learning models are trained and how optimization evaluate their performance. So however, an important question still remains. What happens if a model has been trained and evaluated, but the results are still as good as not as good as expected. In many cases, optimization need to make adjustments to improve the model's performance. This process is called model tuning and optimization. So in this presentation, we will explore how organization improve machine learning models, why tuning is important, and how different optimization techniques help reduce better results. So let's get started. So before we discuss specific tuning techniques, let's first understand why tuning is necessary. So many people assume that once a machine learning model finishes training, it is immediately ready to used. In reality, this is often not the case. A model may complete training successfully, but its prediction may still contain errors. Sometimes the model learns too little from the available information. Other times it may learn too much and become overly dependent on the training data. In some situations, the model may work correctly but require too much time or computing power. Because of these challenges, optimizers organization use tuning and optimization technique to improve performance. Throughout this presentation, we will learn what model tuning means and why it is important. We will explore hyperparameters and understand how they influence the learning process. We will also discuss learning rate and batch size, which are two important settings that affect how model learns. In addition, we will examine overfitting, regularization, hyperparameter tuning, and Amazon SageMaker automatic model tuning. By the end of this presentation, you will understand how organization improve machine learning models after training has been completed. So let's discuss why model tuning is important. Imagine a student studies for exam and earns a score of 70%. So the student passed the exam, but there is still room for improvement. The student may decide to change study habits, spend more time practicing difficult topics, or use different learning techniques before the next exam. Machine learning model work in a similar way. A model may complete training successfully, but that does not automatically mean it is performing at its best. Organization often discovered that prediction accuracy can be improved by adjusting certain training settings. Sometimes even small adjustment can make a noticeable difference. For example, a recommendation system might suggest products that are only somewhat relevant to customer. After tuning the model, the recommendation may become much more accurate and useful. Model tuning helps organization find better way for the model to learn from information. Better tuning can improve prediction quality, reduce training time, and support better business discussion. That is why optimization is often performed before a model is deployed into a production environment. Organization want to ensure they are using the best possible version of the model. So let's move to the next slides. So to understand model tuning, we first need to understand hyperparameters. So hyperparameters are settings that influence how a machine learning model learn during training. Think of them as control that guide the training process. Unlike model parameters, which are learned automatically during training, hyperparameters are chosen before training begins. So let's use the driving example shown on the slide. Imagine two students learning how to drive. The first student uh, practice for only 30 minutes each day. The second student practice for 3 hours each day. Both students are learning the same skill, but their learning experience will be very different because of the amount of practice they receive. Machine learning model experience sometimes similar. The way a model learns can change depending on the setting chosen before training starts. These settings help determine how quickly the model learns, how much information it processes at a time, and how long training continues. Some common hyperparameters including learning rate, pitch size, number of training cycles, and regularization settings. Organization experiments with different parameters, hypermeters values, because there is rarely one perfect configuration for every machine learning problem. Finding the right combination of settings can significantly improve model performance. This is why hyperparameters play such an important role in model tuning and optimization. Let's move to the next slides. So let's discuss learning rate, which is one of the most important hyperparameter in machine learning. Learning rate control how quickly a machine learning model adjusts itself while learning from information. To understand this concept, let's use the mountain example shown on the slide. Imagine you are standing on a mountain during a very foggy day. Your goal is to safely reach the lowest point of the mountain. However, because of the fog, you cannot clearly see the entire path ahead. Instead, you must move step by step and continuously decide where to go next. This is very similar to machine learning model learn. The model is trying to find the best possible solution, but it does not know the answer immediately. It must gradually improve through many small adjustments. Now let's see what happens when the learning rate is too high. If you take very large steps while walking down the mountain, you may move quickly, but you could easily miss important details. You might walk past the safest path or even move away from the best location. Machine learning model can experience the same problem. So a learning rate that is too high may cause the model to make large adjustment and skip over better solutions. Now consider the opposite situation. If your steps are extremely small, you will move very slowly. Eventually, you may reach your destination, but it could take a very long time. The same thing happens when the learning rate is too low. The model learns slowly and may require additional training time and computing resources. Organization therefore try to find a balanced learning rate. A balanced learning rate allows the model to learn efficiently without moving too quickly or too slowly. This often leads to better overall performance. So let's move on to another important hyperparameters called pitch size. Batch size determine how much information the model processes before making an adjustment to itself. To understand this idea, imagine a teacher grading homework assignments. The teacher has two choices. The first option is to grade a few assignments at a time and provide feedback immediately. The second option is collect a large stack of assignments and review them all before providing feedback. So both approaches work, but they create different learning experience. So machine learning models work in a similar way. A small batch size means the model review a smaller amount of information before making adjustment. Because update happen more frequently, the model may react quickly to pattern in the data. However, this frequent update can sometimes make learning less stable. Now consider a large batch size. The model review much more information before making changes. This often create a more stable learning process because decisions are based on a large amount of information. However, large batches usually require more memory and computing resources. This is why organizations experiment with different batch size. The goal is to find a balance between training speed, stability, resource uses, and prediction quality. This is no single batch size that work best for every machine learning project. So let's move to the next slide. So now let's discuss one of the most common challenge in machine learning, which is overfitting. Overfitting happens when a model becomes too focused on the information used during training. Instead of learning general pattern, the model start memorizing specific details. At first, this may sound like a good thing. After all, memorization seems like learning. However, the problem appears when new information is introduced. Let's use the student example shown on the slide. So imagine a student preparing for an exam. The student memorizes every practice questions and every answer exactly as they appear. So during practice session, the student performs extremely well because all of the questions are familiar. However, on the actual exam, many questions are different. The students struggle because the concepts are never truly understood. Only the practice questions were memorized. Machine learning model can explain the same problem. During training, the model may appear highly accurate because it may remember many details from the training information. But when new information arrives, performance may suddenly decrease. So this happens because the model memorize information instead of learning patterns that apply to a new situation. Organization try to avoid overfitting because the goal of machine learning is not to memorize the past. The goal is to make reliable predictions about the future. So now let's explore why overfitting is such a serious issue. Business use machine learning model to make prediction because about situation they have not happened yet. If a model only memorizes old information, it may struggle whenever conditions change. Let's look at an online shopping example shown on the slide. Imagine an online retail uses a recommendation system to suggest product to customer. The model is training using historical customer behavior. During training, the model studies previous purchases, browsing activity, and customer preferences. However, instead of learning general shopping patterns, the model memorizes specific action from existing customers. Everything appears fine while evaluating familiar information. The problem occurs when new customers visit the website. This customer may have different interests, shopping habits, and preferences. Because the model memorizes old information rather than learning broader patterns, its recommendation become less useful. As recommendation quality decreases, customer satisfactions may also decrease. Customer may stop clicking recommended product because the suggestion no longer match their interest. This example shown why organization focus on building models that learn patterns rather than memorize records. A good machine learning model should be flexible enough to perform well even when new information and new situations are introduced. So in the previous slides, we learned that overfitting happens when a machine learning model memorizes training information instead of learning useful pattern. Now let's discuss one of the technique organization used to reduce this problem, which is called regularization. Regularization helps guide the model toward learning broader patterns that can be applied to new situations. To understand this concept, let's use the sports team example. Imagine a coach training a basketball team. The coach could tell player to memorize every moment from previous games. This might help if future games are exactly the same. However, real games are unpredictable. Different opponents use different strategies and new situations appear all the time. So because of this, a good coach teaches player general strategy and decision-making skills rather than having them memorize every play. This help player perform well even when they face situations they have never seen before. So regularization work in a similar way. It encourages machine learning models to focus on important pattern instead of becoming overly depend on specific training records. As a result, the model become more flexible and performs better when new information is introduced. The benefit listed on the slide are important. The regularization and encourage broader learning, reduce reliance on specific records, improve performance on unseen information, and help models generalize more effectively. In simple terms, regularization helps the model learn concept rather than memorizing examples. So now let's discuss hyperparameter tuning. So earlier we learned that hyperparameter are setting chosen before training begins. Example include learning rate, batch size, training cycle, and regularization setting. The challenge is that organizations usually do not know the best value for these settings immediately. This is why hyperparameter tuning become important. Hyperparameter tuning is the process of testing different combination of the setting to identify the configuration that produce the best result. Let's use the chef examples on uh, imagine a chef create a new recipe. The chef may experiment with different amount of salt, sugar, spices, and other ingredients. The first attempt may be acceptable, but small adjustment can improve the final result. After several experiments, the chef eventually discovered the combination that produced the best flavor. Machine learning teams work in a very similar way. Instead of testing ingredients, they test learning rate, batch sizes, and other hyperparameters. Each experiment produces different results. The goal is to discover the combination that allows the model to learn most effectively. This progress may require multiple training attempts, but the improvement can significantly increase prediction quality. Let's move to the next slide. So now let's look at some common approaches organizations use when researching for better hyperparameter settings. The first approach is grid search. With the grid search, organization create a list of possible value and test every combination. Thinks about trying every possible route when driving to a destination. Eventually, you will find a good route, but it may take a lot of time because every option is being tested. This makes grid search through but often time consuming. The second approach is random search. Instead of testing every combination, the system select random combination to evaluate. This approach can often find good result much faster because fewer experiments are required. The third approach is Bayesian optimization. This method learned from previous experiments. After each test, it used the results to make smarter decisions about which configuration should be explored next. Instead of searching blindly, it used information gathered from early attempts. Finally, there is hyperbrand. Imagine interviewing many job candidates and quickly eliminating applicants who clearly do not meet the requirements. Hyperbrand works similarly. It identifies poor performing configurationally and stops spending resources on them. This saves both time and computing power. Each approach has advantage and organization choose the method the best fit their goals, available resources and project requirements. So let's move to the next slides. So let's now discuss how AWS help organization automate the tuning process. Amazon SageMaker provide a feature called automatic model tuning. As the same suggests, this service help organization find effective hyperparameter settings automatically to understand how it works. Imagine a team of data scientists manually testing hundreds of different configurations. This could take a significant amount of time and efforts. SageMaker simplify this process. First, organizations define the hyperparameters they want to explore. For example, they may want to test different testing rate or batches. Next, SageMaker automatically launches multiple training jobs. Each training jobs use a different combination of hyperparameter values. As the experiment runs, SageMaker collects and compares the performance results. The system may identify which configuration products the strongest performance. Instead of manually reviewing every experiment, organization receive recommendation based on actual results. This provides several benefits. It reduces manual experimentation, save time, improve efficiency, and help organization optimize machine learning model much more quickly. For companies working with large machine learning projects, automation automation can significantly reduce development effort while improving overall model performance. Let's move to the next slides. So now let's look at complete real-world examples that bring together many of the concepts we learned throughout this presentation. Imagine an online retail that sells thousands of products through its website. The company uses a machine learning recommendation system to suggest products that customer may interest in purchasing. The goal is simple: if customers receive useful recommendations, they are more likely to engage with the website and make purchases. However, the company noticed a problem. Many customers may receive recommendations that does not match their interests. For example, a customer who frequently purchases fitness equipments might suddenly receive recommendations for products that are completely unrelated to their shopping habits. As a result, customer engagement being a decrease. People are clicking fewer recommendations and spending less time interacting with the suggested products. The company decided to investigate the issue. Data scientists review the machine learning model and determine that improvement may be possible through model tuning. Instead of rebuilding the entire system, they begin adjusting important hyperparameters such as learning rate and batch size. They also perform multiple tuning experiments to test different combinations of settings. Each experiments produce slightly different results. Some configuration improve performance while others do not. To make the process may if efficient, the company may use Amazon SageMaker automatic model tuning. SageMaker automatically tests different configuration and compare the results. After analyzing many experiments, the system identifies settings that produce stronger recommendation. Once the improved configuration is implemented, recommendation quality increase. Customer begin receiving suggestions that better match their interest and shopping behavior. Because the recommendation become more relevant, customer engagement improve. More customers interact with suggested products and business gain greater value from its machine learning system. This example demonstrates how tuning and optimization can significantly improve the effectiveness of machine learning application without completely redesigning the model. So let's move to the next slide. So before we conclude this presentation, let's review the most important concept we learned today. First, we learned that model tuning helps improve machine learning performance after training has been already been completed. Even when the model finishes training successfully, adjustment may still be needed to improve prediction quality. We discussed hyperparameters and learned that they are settings chosen before training begins that influence how a model learns. We explored the training rate and batch size and saw how both settings affect training behavior. Overfitting occurs when a model memorizes training information instead of learning useful patterns that can be applied to a new situation. Next, we discuss hyperparameter tuning and learn how organization test different configuration to identify the most effective settings. We also explore several tuning approaches, including grid search, random search, Bayesian optimization, and hyperblend. Finally, we learn how Amazon SageMaker automatic model tuning helps automate this process and make optimization more efficient. Overall, the model tuning and optimization help organization build machine learning systems that are more accurate, reliable, and effective. So that's it. So this brings us the end of our presentation on model tuning and optimization fundamentals. Throughout this presentation, we explore how organization improve machine learning models after training and evaluation have been completed. So, throughout practical examples such as learning how to drive, preparing of exam coaching, sports teams, and product recommendation systems, we saw how these concepts apply to a real-world situation. Organizations continuously improve their machine learning system to achieve better predictions, quality, and stronger recommendation, performance, and greater business value. I hope this presentation will help explain this concept in a simple and easy to understand way and provide a better understanding of how machine learning optimization works in a practice. My name is Akash Patel, and this presentation is part of my AWS certified machine learning engineering learning journey at Concordia University, Chicago. I would like to express my sincere appreciation to my professor, Dr. Victor Govindaswamy, for his continuous guidance, encouragement, and support throughout this learning experience. So that's it. Thank you so much for watching this video and have a wonderful day.